Hi guys, welcome to Not So Nerdy channel. We are solving the second question of today and it's the 12th question from NeetCode150. It's based on trapping rainwater. It's a hard level question, so let's pay attention to what they are asking us to do. So given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So they have given this example of in heights as 0, then 1, then 0, then 2, then 1, then 0, and so on. And the output is we can store 6 blocks of water, 1, 2, 3, 4, 5, and 6. So how are we going to approach this question? So suppose you have this example, okay, and you can see that you can only have your max height up to 3 because on reaching 4 it's gonna spill. So first we will try to find the maximum height of each index. Suppose you have here 2 1 sorry 3 2 0 4 3 0 1 3 and 2. Okay, so these many blocks you have on each index. So now you need to see that from left hand side these are our 2 pointers. So on left starting from left side we will see that the max height is 3. Next, we will go to the next index and check that our max height is still going to be 3. Then, because they have only 2 blocks here. Now, we will, here they do not have any blocks, so our max height will stay as 3. Then you get a 4 block. So, your max height will get updated to 4. So, this way, it's gonna stay 4 till the end. Now, similarly, for right, we will start from the end, from the last pointer, and here we will see that our max height is 2. Then we go to the next index and our max height becomes as 3. 3. Then you have 3. Your max height is still 3. It's still 3. Now here it changes to 4 and it stays as 4 throughout. Okay, so looking at this, we realize that the amount of water that can be stored depends on the minimum height of the left and the right side. Because if you consider the max, the water is going to spill out. That is why you have to consider the minimum height of in between the left side and the right side. So we can compute a formula to calculate the water stored on each index. As suppose you have, first you will see that what minimum height you have. Okay, here our minimum height is 3, but the number of blocks is also 3, so we can store 0 amount of water. Next, here our minimum height is 3, but your number of blocks is 2, so you can store 1 block of water. Similarly for the next ones. So here we are making a formula as minimum of left and right minus the current height of the block, which is height of height of the current block, say I. Okay, so let's compare. So here we have 3 as our minimum and the current height is 0, so you can store 3 blocks of water. And now here it's 4 and your block is 4, so it's 0. Now here you have 3 as right hand side, 3 as your minimum block. So, and here it's also 3, so again it gets 0. Same for 3 and 0, so it becomes a 3, And that's how you compute that. You're storing 2 blocks and then 0, 0 amount of water. And then you add these to get your total water stored. So this is the logic which is happening in this question. Okay, just let me zoom out. So this is the logic that's happening here. Now this is our main formula, but we do not want to use these memories. Okay, we want to shorten the memory usage. So instead of taking separate memory blocks, we can simply do one thing. We can compute it in a single way. So how are we going to do that? We are going to check initially that whether left max of left is less than max of right or not. So if max of left is less than max of right, we are only going to focus on the left side. We are not going to compute the right side. Okay, so every time we can simply check it and find a solution. I am going to switch to the coding part to explain you better. Okay, so initially if there is no height, we are going to return 0. So if not any height, return 0. Okay, now we are going to initialize our 2 pointers. Left equal to 0, right equal to length of height minus 1, and we are also going to have 2 more variables, max left, which is going to be the height of left. Initially we are initializing it with that, and max right equal to height of right. Okay, so, and of course we need to check, we need to initialize our total water. So let's give total water equal to 0. Now we are having while left is less than right, because we have to compare the left pointer and the right pointer. So if height of, here we are comparing that if height of left is less than height of right, we will simply okay, so here we are going to check whether the height of left is less than height of right. If it is less, we will update our values to, we are only going to focus on the left side, as I said. So it's gonna be left, maximum left will get updated to max of both the values, which is left, sorry, height of left, just give me, comma, max left. So as we saw in this, we will start, okay, and we will update our max value. So whatever is the current height, comparing it with the maximum, we will update our max value, and we will keep on updating as we iterate through it. Then we will okay, now here as we saw that we are subtracting the current height with the minimum of left and right. So we will have our total water as left of max of left minus height of left, because here we are computing that the max, we are updating our max value, and then we are subtracting the current value, and whatever that current value is, this part. Okay, So let's say here our max value is 3 and our current value is 2. So we will add the the left out part in our total water. So that's how we will keep on computing it. And of course we will increment our left side. Now this is the case when height of left side is less than the height of right side. Otherwise, else we will do the maximum, we will update our right max to max of height, the current height of right and max right. Then we will add the total water plus equal to, we will simply have max of right minus height of right, and then we will decrement the right index by 1. So this is the basic working of it, right? And finally we will return our total water. Okay, now let's try running it. So I hope you understood what we are doing here. Basically, we are updating our maximum heights and simply subtracting the current height and getting the left out part, and that will be our total water. Like it will add up to the total water. Similar for this and the so and so forth. Okay. Thank you.